Cool. So yeah, I'm Tenzong from Bloomberg, and this presentation, the proposal is co-worked by Google and Bloomberg and Nigeria. So it's a teaser proposal on AsyncContext, and we are here today to introduce the proposal again and to the working group here. And the last time that we introduced the AsyncContext proposal was at 2023, so it's about 2 years ago. So things have been changed since then, and we would like to have an update about the proposal and seek more feedbacks on the latest proposal, especially about the web integration part, because I think that's mostly important for the proposal to be successful. And great. So what's AsyncContext again? So just to recap people about the proposal quickly. The proposal is about implicitly propagates value storage through async tasks and preserving their values across async boundaries. So from the example on the right of the screen, we can see that there are two set timeout being scheduled, and we schedule a 1000 millisecond task first and a 500 millisecond set timeout second. But the task being scheduled as a second one will be triggered first. So, but still, with AsyncContext, we can get the correct value even though the tasks are being concurrently scheduled and evaluated. So it's been different from a context value that's being attached to the global disk, because if a value being attached to global disk, they are constant and shared after the concurrently scheduled tasks. So AsyncContext is being able to preserve the value just for a single async task, and they are isolated from the async task concurrently scheduled. And the primary use cases for AsyncContext is that it's perfect for user-land tracing, especially about libraries like OpenTelemetry, which puts the tracing context on the async context variable storage so that the tracing context will be preserved across the function building syntax like async await and generators. So the OpenTelemetry will be able to trace a tree of async operations in a JavaScript applications, and it's also suitable for front-end web software navigation metrics in browsers, because there I can see that there are efforts like in Chrome that implements task attribution, and the concept is pretty similar between task attribution and the AsyncContext. And actually in Node.js and in Chromium, they share the same fundamental via API, and they are being propagated similarly. I think what we are going to do is that we are going to unify how the values are being propagated through the async task and the async boundaries, and we'll talk about this later. And as a third point, we also found that frameworks are pretty interested in the AsyncContext and how it can potentially enable more use cases in the framework APIs. And I linked to the framework feedbacks in the slides, and we received feedbacks from frameworks like React and Solid, so many of them. So let's have a look on the AsyncContext API. The AsyncContext is a namespace of two classes, The first one is AsyncContext variable, and it is intended to be a single purpose value storage, which you can view it as a JavaScript variable, but it is preserved across async tasks. And for each async tasks, it has its own value storage. And the second one is the async context snapshot. It is an opaque value mapping containing every async context variable. So through async context snapshot, we will be able to allow the userland task scheduler to save context mapping and restore it later. For example, if we implement a userland queuing strategy, the userland library can save the async context snapshot at the time when we enqueue the task and restore the snapshot with snapshot.run at the time when the userland task is being actually evaluated. So what's changed since 2023, the last time that we presented at this working group? And the essential point is that we split the async context interface to two classes that we are just presented. And because the primary reason behind that is that they target different audiences. And as you can see, that async context variable is suitable for general library owners and applications. They don't care about the how to schedule a task. They don't implement their own scheduler strategy. So it's only these libraries and applications only cares about from at a specific time what's actually being active and what I can get from the async context variable. And from that variable, I can identify what's the active task that is being evaluating. So it allocates a single purpose value storage like for OpenTelemetry. It can save trace context like trace ID, span ID into a single async context variable. And for some applications, they can save their task IDs into the variable. So every library should create their own async context variable and its single purpose. And for async context snapshot, it's intended to be used by libraries and frameworks who implement their custom scheduling strategy. And like if a userland, like for a userland promise or userland task queues, and so that they can restore the correct current active async context for the userland tasks. So the current proposal is at T39 process stage 2, and we are seeking for web integration inputs because it will be essential for the proposal to be successful on the website, and because libraries like OpenTelemetry, userland tracing library, and applications would expect that the proposal should work with web APIs, especially that web APIs that schedules a task, and their context can be propagated correctly across these web APIs. So the questions for web integrations are that what APIs need async context propagation and what should not. And as a advanced ask is that what web APIs can also be built on top of async context and be benefit from the context propagation that async context provides. So for the first question, we will need to look into web APIs like trivial task APIs, set timeout, set interval, and also for APIs like promise returning, APIs like fetch and stream readers. Also, I think there are APIs like events and performance observers that, even though they provide a single shaped API, but they can be used in various and pretty much different situations. So they can be we'll talk about this later, case by case, well, by their use case categories. And for the second question, I think we can look into like exposing initiator context on performance timing entries, like resource timing. And we can also look into how like task attribution can be built on top of AsyncContext, and how the metric software navigation metrics can be saved in the AsyncContext. And also we can look into the scheduler yield being benefit from the implicit propagation of AsyncContext, because the AsyncContext can preserve context across async await, which is not possible for scheduler yield, that if to preserve the priority and signal across the await. And there is a issue about standardizing web variables like abort signal and task signal. I think we can also look into defining these standardized variables for web APIs. And let's take a look into how the integration of web APIs will be like. So we identified that there are categories of web APIs, and the first one is the web APIs that are based on promise. So promise are already being part of the AsyncContext 2 specification. So with AsyncContext proposal, we can already define the semantics on promise and how the AsyncContext will be propagated across the promise boundaries. So for web APIs that are based on promise, they can automatically get the integration support, and for APIs like fetch or stream readers, and they will preserve the context across await, the await keyword. And for web APIs that are event driven, they do not get the integration automatically because that's not part of AsyncContext 2. But we are still would like to look into how to preserve the context across events, because there are events that are fired for triggered for network I/O or local file system I/O, and we would like to preserve context for these events. But for events that are triggered by user interaction, we believe that we don't, in this case, there are no meaningful context for this kind of event, and we can define that the context for events that are triggered by user interaction can be just empty context. So that's what we are going to define in the web spec, and that's what we say as web integration, because we need to know for which events and what their context will be in their event listeners. So that's part of the web integration. And we also have a analysis document for the web APIs. So it's linked in the slides. Please feel free to comment on it. And we talked about a lot of different cases in which case, like when to propagate and when not to propagate. And the general approach that we when we look into these cases are that the web API should propagate the AsyncContext if they schedule a task on the event loop, like if a JavaScript code invokes the fetch API or the JavaScript code invokes the XHR API, they should propagate the async context because the JavaScript code schedules a task via the web API, and we would expect that the context being propagated. But the one case that we would say that the context must not be propagated is that context should not be propagated across agents, which means they will not be propagated to workers, to worklets, or to external process. And they should not propagate across document and navigation. So which means that when we navigate to a new page or new document, they should not preserve the context to avoid leak any information that are saved in the async context. And there are also requests to integrate with the performance observations. There are two cases. The first case is the user-land observability tools like OpenTelemetry, and OpenTelemetry instruments the fetch API, and it can collect the resource timing performance data from the performance observer. However, it's been greatly impacted by the lack of initiator context. So it has to pay the computation to find the exact resource timing entry for its associated fetch call to be able to associate them together and collect the resource timing data. So if the OpenTelemetry can get the initiated context from a resource timing entry, that would save a lot of comparison in the user-land observability tools. And the second one is that if we can augment other performance timing entries like container timing, and to augment it with the initiator context, so that these entries could also be benefited from the async context and the user-land task informations. I think Jason would be able to explain more about this if Jason would can do that later. And I think that's all the presentation today. And we can jump to the queue if we have any questions or